So thank you, Eva, and good morning, everybody. So at Mocean Energy, we have adopted a start small, go big approach. And this is really anchored in the off-grid markets, which we're talking about today. So I've included lots of clips and video just to try and give you a sense over the next 5 minutes of how real and within reach some of these solutions really are. And then I think we'll have plenty of time to get into the details in the Q&A. So a key concept around off-grid use cases for wave power is that we are trying to provide solutions over and above electrons per se. And so this often translates to the need to provide continuous, or what we call always-on power at sea. And we can do so by, first of all, optimizing our wave energy converter, but also hybridizing wave power with solar power, in this case on the top side of our hulls, and also battery storage within our hulls and subsea. So this is really the strategy we've been pursuing with our award-winning technology. But what are the sort of challenges that we're trying to address here? The drivers in off-grid markets are really 3, maybe 4. So decarbonization is an obvious one. Electrification, economics, so reducing costs, and growingly so maintaining social license, particularly in the oil and gas sector. These apply to a variety of applications in a variety of markets, all of which are global. And what we'll focus here is just on umbilical remediation, which essentially means providing power once cables have failed offshore, and displacing long cable offsets. Umbilical remediation market itself, we estimate to be worth over £1.5 billion. So by no means niche. And in these contexts, wave energy is really an enabler. Why so? And what do solutions look like? So here we're showing our first commercial product, Blue Star, which builds on the prototype you saw on the previous page, feeding a subsea microgrid. So the value here is that we no longer need to rely on a often long umbilical, providing power from shore or from the nearest host platform. Umbilicals have long lead times, they're cost intensive, they're carbon intensive. And so with our system, we can provide continuous power, so reliable, renewable power locally to where it's needed. So what we're showing here is just the provision of power reliably over a 12-year period to subsea assets, without dropouts and with appropriate redundancy levels. And this is what we've demonstrated through a project called Renewables for Subsea Power, or RSP, very recently, where we've connected our BlueX prototype to a subsea microgrid. And the microgrid was composed of a subsea battery module, which you see in the skid, the yellow skid on the quayside in the bottom left. Attached to that is an AUV dock, an autonomous underwater vehicle dock, and also a subsea control module within the skid itself. You can see the very small umbilical winding on the quayside, and then this was just pre-deployment. The key thing here is that we were working with complementary technology developers, a subsea integrator, and crucially with end users as well, which in this case were oil and gas operators, including 2 super majors. So the idea was to not just demonstrate the WEC, the wave energy converter, but really demonstrate an integrated system solution. So we were at sea for 13 months consecutive, adding to our track record, collecting at sea data, and we were able to, let's see if the video starts. There we go. So this is a view from the top side of our device looking forward. So we were able to validate performance. So this is driven by the IEA OES metrics, which many of you will be familiar with. Demonstrate survivability. There we go. And you can see actually here the device sort of diving through the steeper waves. And that's part of our passive survival strategy in order to shed the more extreme hydrodynamic loads. And then finally demonstrate reliability. So this is about reliable power delivery in the summer months where you have less wave intensity, and in the winter where you have more, including storms, equipment integrity, and also communications uptime. We've also carried out some early stakeholder engagement in islands and remote communities. We're showing here Isla Santa Maria in Chile, where myself and Cameron, our managing director, traveled to in February. Santa Maria is an off-grid island in the Biobío region, and we were exploring the feasibility and attitudes towards a wave-powered local grid. And this was done alongside local partners, the municipality of Coronel, and MERIC, the Marine Energy Research Institute of Chile. So some exciting opportunities ahead. Where next? So for Mocean, new horizons really lie across 4 areas. The first one is expanding our network of partners and strengthening those relationships that we need in order to deliver some of these system solutions. Undertaking studies, which we're doing so more and more so, and this is really working with prospective customers and stakeholders in order to do further demonstration deployments and build use cases and case studies. Technology qualification, which we're carrying out with 2 of those super majors. And finally, scaling up, which is really the ultimate goal. Thank you very much.